In this video, we are going to talk about isValidBST. We are given a tree and we have to define whether it's a valid BST or not. How do we define if it is a valid binary search tree or not? For that, we have 4 rules. First, if every node value in the left subtree is less than the root node value, if every node value in the right subtree is greater than the root node value, if left subtree is also BST, and if right subtree is also BST. In this example, this is a valid BST because every node value in the left of the tree is lesser than the root node, and every node value in the right subtree is greater than the root node. Whereas in this example, we have 7 which is greater than 5, which is the left subtree for this root node. Even though it is lesser than 10, but it breaks the BST rule in the child subtree. So this is not a valid BST. How do we solve this problem? We solve it recursively. So recursively we check for each node if it comes in the range of a valid value. How do we define the range? It can be anything, any infinite number or any minimum or maximum number for the root node. But for the left node, it has to be lesser than the root node. So the minimum can be any minimum value. It can be any infinite minimum value, or you can provide nil as well. And the maximum has to be the root node. In the right subtree, the minimum has to be the root node and maximum can be any infinite value. Similar goes for the left and the right subnodes. And as we can see for 15, the maximum can be 20 as its root node is 20, and the minimum can be 10 as the root node of this subtree is 10. So this value has to be between 10 and 20. Over here, this is not a valid BST because 7 does not come into this range. The minimum can be anything, but maximum has to be 5, and this value is 7, which is greater than the root node. This is the pseudo code for isValidBST. We have root node and minimum and maximum. Minimum and maximum can be any infinite value, or you can pass nil as well. For this recursive call, our exit condition is if root node is nil, then we will return true. If maximum is not nil and root node dot value is greater than max, then we will return false. If minimum is not nil and root node dot value is lesser than min, then we will return false. And then in recursive call, we will check isValidBST for our each child nodes. For left node, we will pass min as the infinite value or nil, or for max, we will pass root node dot value. And for right nodes, we will pass root node dot right as root node, and min would be the root node dot value and max will be the infinite value. And if these conditions are true, then we will return true, otherwise we will return false. This is the solution in Swift language. I will be giving link for solution in other languages as well, so you can check the description. Thank you so much for watching. If you liked the video, please do subscribe and like. Thank you.